Hey all, let's put the chain rule to the test. See how much we can really exploit this thing. Taking the derivative of 3 monster expressions. Remember, you want to separate this kind of thing into 2 parts. The outer function and then everything else inside. So that'll give us f prime of x equals cosine of sine of x. Times, okay, now we're done with that part. And maybe I'll get reeling close here. We're looking at the next outer function, which is that part, right? That sine. Take the derivative of that guy. Keep the inside the same. It's like this is going to be a little bit long. We'll move this guy to the side. Okay. Then, same sort of thing applies, right? All right, want to focus on that. Take that derivative. And then we have just one derivative left, right? So let's take it. All right, that's the derivative of that. Let's go on to this guy. Same exact sort of thing. So e to the x is its own derivative. Remember, we want to look at this guy, the outer function, and then everything else. Derivative of the outside is e to the x. Keep everything else the same. Go a little bit further inside. Taking a look at that outer function and then the inner functions. So, same sort of deal, right? You just sort of repeat this process. Maybe you can even see what we're doing here. And then you have just that one last little piece right there. I'm done. Right? Well, at least with that part. Right? And now on to this next part, which is kind of more the same if you remember the first part. But let's see what it is. Well, we're going to look at sine and then everything else on the inside. So it's going to be cosine of all that junk on the inside. Whoop. 2, 3, 4. All right, now we look at this function and everything on the inside. So that's going to be times negative sine. Please remember to put a parenthesis there so it doesn't look like you're subtracting. Same sort of thing. Derivative of tangent. And then last but not least, derivative of secant. Ugh, that's secant tangent. Let's move this a little bit so we can, whoops, nope. Do that, yeah. Just a little bit. Okay. And that's our derivative.